よろしくお願いします。とりあえず簡単な自己紹介を言っていただいたら。
はい、こんにちは。皆さん、私はアレックス・メイリンズと申します。日本原子力研究開発機構の、研究員ですね。で、2014年から日本に引っ越してきて、それ以降、日本原子力研究開発機構で研究を行ってきました。で、私の専門は主にあの物理学の研究と計算学の研究です。で、仕事で複数のプロジェクトに関わっていますが、あの一番多くやってる研究は福島の除染仕方とか計算学のソフトの開発をやっています。
いいですね。日本に来るきっかけについてちょっと話せますか？
はい、初めて日本に来た時は2008年でした。その時はイギリスのブリストル大学で修士をやってて、でその時は私の先生はあの東京大学にある顕微鏡を使いたかったので、あのその1ヶ月のあの研究の出張を
うん。
一緒に日本にあのきあ行きませんかの招待がありましたので、そこから初めて日本に行きました。で、その日本での研究を楽しか楽しかったので、日本の人生も楽しかったので、あの博士の時に複数回日本に研究をしに来て、その後日本は好きになりました。
うん。じゃあ研究の、出張とか、日本のことをよく知って、でちょっとその後、もっと日本で働けたらいいなと思って、こっち来た2011年2008年こっち来て、JAEA で仕事が始まったってことですね。
2014年から原子
14
力研
年失礼しました。
究、はい、研究員に
はい。
なりました。
うん。で、仕事の内容、複数のプロジェクトがあるとおっしゃってて、オープンソースの活動もありますので、それについてちょっと話せますか？
はい、2年前からオープンソースのソフトに貢献を始めました。あの主に私が開発しているPython のライブラリ、Radioactive Decay というソフトをあの開発しています。そのソフトは放射生物の崩壊を計算ができます。そのソフトは2020年にGitHub と Python パッケージインデックスで公開して、で、今までに多分複数、今、バージョン0.43になりましたので、複数回公開しまし
うん。
た。
結構、そのパッケージ使ってる人とか使ってる会社、団体あります？
はい、詳しく測れないんですけど、正確に測れないんですけど、ユーズが測れないんですけど、コンダフォージとPyPy のダウンロード数は、あの、数千回がありますね。はい、今までに。
素晴らしい
はい、
ですね。で、オープンソースするまでの道はちょっとなんか抵抗とか、あの、JA が反対するとかそういうのはなかったですか？
あの、このソフトはJA から初めて GitHub で公開しているオープンソー
う
スソフトで、
ん。
今までに原子力研究開発機構のウェブサイト、ホームページだけで、なんか同僚がソフトが公開しましたので、 新しいプラットフォームで公開するのは、新しい許可を許可が必要でした。
うん。
だから、それを、ちょっと、許可が出るまでに、数ヶ月かかりましたけど、なんか抵抗というより、新しいことですから、
うん。
ちょっと時間かかるだけだと
うん。
思います。でも、
うん。
なんか
ああ。
同僚手伝ってくれましたので、感謝します。
うん。いいですね。まあ、他の、まあ、他のエンジニアはちょっとなんか、まあ、仕事で書いたコードをオープンソースしたいけど、どうすればいいとか、そういうちょっと疑問を持ってる方が結構いると思います。なんかアドバイスとかあります？
企業で開発しているソフトなら、あの、はい、上司からの許可が必要ですよね。オープンソースするなら。だから、オープンソースのメリットをちゃんと説明すれば、オープンソースすれば、なんかどの価値を、かかる、どの価値を持ってくるとか、説明して、あの、はい、挑戦してみてください。
うん。
オープンソースの価値というと、あの、とりあえず、自分の能力、開発している人の能力は、あの、増やせるし、あとは、あの、オープンソースで、あの、ダウンロードしたユーザーは、バグを見つけたり、ソフトの開発をなんか提案したりしますので、それで、自分の企業のソフトの、レベル、自分の企業のソフトの、あの、はい、能力は、
うん。
増えるから、その価値を上司に説明したら、はい、可能性があるかもしれません。
うん。まあ、おっしゃる通り、オープンソースにはいろんなメリットがありますね。そのコード自体だけじゃなくて、スキルアップのチャンスとか、まあ、ユーザーも増えるから、まあ、QA みたいな活動になるし、うん、いいですね。
はい、その通りです。
あの、まあ、
実は、JAEA が開発している放射
うん、
線の輸送コードになります。あの放射線はなんか放射性物質から放出されて、あの飛んでるうちにいろんな物質と反応して、向きを変えたり、エネルギーも変えたりと、被爆を与えたりので、それを物理的な、根本的な物理的な理論からシミュレートができるソフトですね、フィッツは。
うん、うん、
で、フィッツ
そ
は、はい、多分数十万人のユーザーがあります、世界中、今までに。
う、うん。
結構成功しているソフトです。
もう、うん、そう、フィッツは一応オープンソースだけど、ちょっと特別なケースですね。
はい、原子力関係のソフトですから、あの輸出管理の規定は結構ありますので、だから、誰でもダウンロードができないですね。ユーザーは登録してから、あの、えっと、なんか原爆を作らないユーザーだった
う
ら、
ん。
はい、フィッツチームがそのソフトのソースとバイナリをはい、配布します。
うんうんうん。そうですね。まあ、そう、核兵器が作る恐れがあるから、ちょっと制限かかってしまうけど、うん。まあ、普通の企業のコードをオープンソースするには、そこまでのハードルはないかもしれないですね。
はい。
うん。
フィッツ、なんか原子力関係のソフトはなんか
うん。
特別なケースですね。
うん。すいません。
3D トラスについても、
ああ、はい。
言いました。はい。3D トラスは、あの、 それはフィッツとの連携するソフトです。3DS は、環境と、なんか福島にある街を、
うん。
モデル化しするソフトですね。
うん。
衛星画像を使ったり、地面のモデルを使ったり、フィッツに入力するモデルが作成できます。そのモデルが含めているのは、建物と木と道路と田んぼとか、でそのモデルで福島で汚染されているところのなんか一番効率的な除染仕方とか、ヒートのヒートバックの計算ができますので、福島の回復にあの、はい、福島の回復の活動に貢献しているソフトです。
お、いいですね。やっぱり、それもオープンソースになる予定ですか？
はい、2年後、1、2年後、
はい。
はい、100%完成してから、オープンソー
うん
ス化
うん。う
にする、
ん。
予定があります。
はい。まあ、いろんなプロジェクトやってる結構、まあ、きっと楽しい仕事ですね。でも価値もありますし。うん。まあ、今日いろいろ話していただいて、本当にありがとうございました。
こちらこそありがとうございました。
Can you tell us all about your career and how you ended up working for the Japan Atomic Association?
Yeah, so thanks for, first of all, thank you, Lloyd, for inviting me to be part of this event. So, my name is Alex Malins. I work for Japan Atomic Energy Agency. Um, and I guess that this all started when I was a master's student at the University of Bristol. Um, when I was young, like none of my friends or family had ever been to Japan. I never envisaged ever coming to Japan. But while I was studying my master's that was in physics, I was studying glass in particular, um, the physics of how glass is formed and whether it's a solid or a liquid. Um, my supervisor was coming to Japan to use a special microscope that was here in the University of Tokyo. Um, and he asked me, do you want to come along? This was 2008 was the first time I came to Japan for 1 month. And I really enjoyed it. It's a great country, fantastic experience. And I continued that project on to my PhD with the same supervisor in Bristol and professor at the University of Tokyo. So I spent about a year um, in Japan during my PhD. So at that point in 2011 was the point of the earthquake and the tsunami. Um, and I was very grateful for the opportunities Japan had given me and the experiences I had here. That I always had in my back of my mind, I kind of wanted to come back to Japan. But before that, I had to go back to the UK and finish off my PhD. And I worked for 2 years in an engineering company in radiation physics in Bristol in the UK. And then after that, in 2014, I decided to take a postdoc at JAEA to try and give back something to Japan if I could in any way. Try and help
Okay.
Japan recover from, the Fukushima accident and kind of decontaminate the land in Fukushima and help recover life there.
Japan has kind of been on your radar for quite a while before you came then.
I first came in 2008.
Was
Um,
that a long
1 month.
period of study, like a year or?
That was 1 month initially,
Uh-huh.
and then during my PhD afterwards, I came for about a year in total
Mm,
over 3 or 4 different research trips.
I see.
So my supervisor would come and use the microscope, and I was a computational scientist, so I could just bring my hard drive at that point and
Yeah.
with my data, plug it into a computer at the University of Tokyo, and then continue my computational physics work.
So then you did the couple of years in industry, decided to move into a postdoc in the JAEA.
Yeah,
And that's where you've been for how many years now?
it's 7.5 years now.
Oh,
So
wow.
I was a postdoc for 3 years, and then I just became a staff member in 2017.
Hmm.
So a scientific research staff member.
Mm. So the Japan Atomic Energy Associations, maybe not everyone is quite familiar with the organization. What do they do? What's your kind of remit?
So JEA is a government-funded research laboratory, um, and JEA's remit is to use radiation technologies and nuclear technologies, not just for nuclear power generation, but for medical physics, so cancer treatments, for space exploration. So some of my
Mm.
colleagues work on protecting astronauts from the radiation in space, and also basic physics research. So a lot of my colleagues in my office in Kashiwa near Tokyo work on simulating materials using quantum physics methods. I've worked on developing a microscope which uses neutrons at a facility called JPark. Um, and that's useful for just basic science research of looking um, inside small biological samples or
Mm.
small robotic samples is another thing that it could be used for.
Uh-huh.
So robots have very small motors, and to look at the parts and look at the wear and tear in these motors, we could use a microscope like the one we've been developing.
Mm. I see. So it's kind of quite cutting edge research with hopefully applications in not just one area, like not just nuclear power or something, but many different related areas coming from this tech. Yeah.
Yeah, in fact, in my office,
Mm.
almost no one works on nuclear power. Um, One of the main things we work on is obviously decontamination of the environment of Fukushima,
Mm-hmm.
and um, as I mentioned, just fundamental physics,
Mm.
fundamental uh, computational chemistry, um, with with applications that are wide ranging, as I just stated.
Mm. Mm. Okay. Yeah, it sounds like some really fascinating stuff. It doesn't sound too far from academia, I guess, in my mind. Do you find any big differences between your sort of university and academic career and your current work, or is it a
Yeah,
smooth
so
transition?
it's not far from academia in the sense that we publish papers and do research, but it's a lot closer to the real world, if I could call it like that, because most of the people I work with are government bodies such as the Ministry of the Environment, um, Ministry of Health, and so on here in
Mm.
Japan, or also local municipalities in Fukushima Prefecture. So these organizations come to us maybe with some data of some radiation measurements or um, some issue that they want us to look at, and then we provide kind of radiation physics expertise
Mm-hmm.
and computational science expertise to try and help answer their questions. So there's a mix of both the academic side of publishing papers, but also, I guess, kind of a consulting side. So when I worked for 2 years in the UK, it was an engineering consultancy.
Right.
And it's similar to that. We have people who give us uh, grants to um, answer study their sites and study their particular problems.
Mm. Excellent. So, I mean, obviously, you're finding it kind of worthwhile and enjoyable work because you've been there over 7 years now.
It's been absolutely fascinating experience.
Mm.
I guess coming from the UK, both of us, the
Mm.
wonderful thing about Japan is it's a real adventure. Things are different here; they're done
Yeah.
differently. So everything is new and novel, and
Mm.
every day is kind of fun. You learn something new. you don't obviously get it right all the time first time because you're not completely completely level with how the culture works and how the business works, but it's that newness and novelty which I really enjoy.
Yeah, me too, definitely. I think every day is definitely an adventure in so many different ways. It's a good chance to segue onto my next question about a lot of people watching this will maybe be sort of non-Japanese engineers thinking about careers in Japan or thinking about career changes in Japan. I wonder if you have any advice or experiences that might be useful or helpful for people maybe from the UK, America, or somewhere else thinking about a career in Japan. What would you tell them?
I guess when you're thinking about changing jobs or trying a different role, it's very easy to fall into the trap of just preparing. So just working on your resume or just working on side projects to get yourself ready. But my advice would be is just to start applying. So if there's something you think you can do, you might not necessarily have all the requirements that are listed on the job description. Start applying and get into the process of speaking to people, speaking to hiring managers and recruiters, because it's very easy just to delay and think you're not ready. So give it a go. And then the second thing is Japanese skills are very important in Japan. Yeah. It's not, obviously, learning Japanese is a very, very long and takes many hours, that journey, but it dramatically increases the number of people you can work with when you're here in Japan. So the time input required is not for everyone, but when I first came in 2014, I was about JLPT N3, I think. And I saw a big improvement in what I could do with my colleagues when around sort of 2017 to 2019, I really put in a big effort to improve my Japanese. And that carried a lot of benefits. Obviously, there are roles in Japan where you don't need Japanese, but for a lot of the interesting stuff, Japanese is very important.
Yeah, I have to agree with that. Especially down here in Fukuoka, English-speaking companies do exist, but they're few and far between. Even in Tokyo, you limit your options if you're only English-speaking.
Yeah, exactly.
Yeah, just moving on to some more maybe software-related topics. I know I found out you worked on a few different open source projects. One was called Radioactive Decay. It's like a Python library. Could you explain what that does and how you put it together?
Yeah, so Radioactive Decay is a library for Python, as you stated. What it does is, if you have some radioactive atoms, over time these decay into another atom. And what happens is you can form chains of where one decays and forms another radioactive atom, and that decays and forms another one, and that decays and forms another one. And moreover, they can kind of split in two. So one radioactive atom can decay in 2 ways or 3 ways to form different atoms. And I was just looking for open source radioactive decay code that can calculate how much of the different atoms you have in the future. And I couldn't find anything that was open source and satisfactory. And by kind of chance, back in 2014, I made like a small radioactive decay code in Python, just for kind of an afternoon's project at work, because I found an interesting paper on how to solve this problem using matrices quite easily. And then I didn't really do anything with it until about the end of 2019, where I found that there's no kind of satisfactory decay software out there. So I asked JAEA, would they let me publish it open source on the Python package index. And that's how it all started.
Yeah, so was it relatively easy to actually make it open source? Because I know a lot of engineers are worried that, they write some code at work or they use some code at work, but they don't feel like they can open source it. Was that an easy process?
Yeah. So I guess in JEA, one of the main remits is to contribute to Japanese technologies and to Japanese societies. It's not a profit organization. So already a number of my colleagues in the Computational Science division of JEA had published open source software. So there was already a example I could follow in that respect. For profit-making organizations, it's a much harder sell to try and get your organization to publish things open source. But it depends what the business model is. So a lot of the big tech companies like Google and Amazon and so on, they publish open source software to sell other parts of their ecosystem. So it might be their cloud computing services, or some companies do it for IT consultancy services. So as long as there's a business model there that you can justify it to management, hopefully you get permission to do it.
I think that's an excellent point, that if, even if you're a profit-making organization, there are good reasons to do open source if it fits with your business model. That's a great point.
And the other thing I would say is it's highly valuable to your staff. Your staff's skills will improve massively by the process of not just coding the software, but everything that goes around with publishing open source. So writing documentation, good, clear documentation that means users can start picking up your software and using it easily. Building a website for your software. And also, another benefit of open source is you get feedback from users. You get users, if your software is any good, you get users quickly, and you get feedback from the users who identify bugs or have suggestions about what they need in the software. So if you are a for-profit making organization, you can get free market information, so to speak, about what customers need, and also to improve your own technology. Yeah.
Great. Yeah, great insight there. Maybe it's my kind of bias, but I feel like maybe companies in Japan are a little bit slower on the uptake of things like releasing things open source. They're a little bit more risk averse and wary about what are the downsides and what are the implications of making something open source, whereas it's kind of taken hold a bit more in other places.
Yeah, I guess that's true, but I think things are changing. Open source is getting bigger and bigger, I feel, especially in the technology sector. So most big technologies now start open source. So if you want to stay on top of what's modern, I think organizations will more and more be open to both contributing to and using open source software.
Excellent, yeah. So there were a couple of other pieces of software that you were involved with. I don't know your level of involvement of these. So one of them is called FITS and one of them is called 3D Address. Can you tell us a little bit about those two?
Yeah, so FITS is it's a radiation physics code. So with radiation, you have different types of radiation, like gamma rays or beta electron rays and alpha rays. So what FITS does is FITS calculates if you have some radiation that originates at one point, say in a let's say a CT scanner at a hospital. So FITS can calculate where the X-rays from the CT scanner originate and how they pass through the body, and how they can also calculate how the image will look from the CT scanner. So FITS is, I say, this is a specialist radiation transport code. It's highly successful because JAEA gives it away free, both to everyone in Japan, but also to researchers globally. So one thing I worked on in FITS was making FITS more efficient for calculating radioactivity doses to people in Fukushima Prefecture. So in Fukushima Prefecture, what we have is the radioactive fallout, which has spread all over the land. And then these gamma rays that originate from the fallout can travel hundreds of meters in air before interacting and causing a dose to humans. So what you need is a very big model. You need a model which is about 1 kilometer by 1 kilometer in size to calculate the radiation dose to the person.
Because it's coming from just so far away and from so many different places.
It's coming from everywhere, but because gamma rays are very energetic and the air is basically nothing, right? Air has very low density, so gamma rays can travel. I think the sort of around the 300 meter length scale, so they can travel about 300 meters before the intensity halves. So you need a very big model to calculate accurately how much radiation a person or an animal or some vegetation like some trees are absorbing. So I worked in a way in FITS of, instead of starting the radiation from all over the base of the land and simulating it, but then you're not sure if the radiation reaches the target where you want it to get to, I worked on a kind of reverse method where you start it from your target and you transport it backwards through time and space. So they undergo reverse physics interactions. And then it just basically, it makes the computation much more efficient because your target is very big in this scenario and your source is very small. So the amount of simulation work you do is much more effective at getting the answer you want.
Sounds a little bit like things like ray tracing and ray casting in 3D graphics. Maybe I'm completely wrong, but
it's very similar. So the physics is very similar, but the energies are different. So obviously ray tracing, you're looking at light, but FITS, we're looking at gamma rays, which are basically highly energetic light particles, highly energetic photons. And the second piece of software you asked about is called 3D Address. So 3D Address is kind of like an add-on for FITS. So I just mentioned you need these very big models of the land in Fukushima Prefecture. So what 3D Address does is it makes these models which you can input into FITS. So 3D Address takes aerial photographs of the land, and it takes some land model data like digital terrain models or digital surface models. These are models which tell you how high objects are on the land and what the shape of the land is. And using 3D Address, we can build these models with buildings and trees and so on, roads, farmland, which we can then put into FITS to make more realistic calculations of radiation doses and radiation levels. Because before when we started in this field in 2014, most of the models were very simple. So there used to be flat land with no buildings or no trees on them. So to improve the accuracy of the models, we started developing 3D address.
Is that open source and freely available as well?
3D address, we're working towards open sourcing it, yeah. So that's the goal. But yeah, maybe 1 year or 2 years later, that'll be open sourced. FITS is open source to users, but users have to be licensed to use the software because it's used for nuclear technologies. It's subject to strict export licensing laws. So each user has to come from a country which isn't developing nuclear weapons, for instance. So users can contribute to FITS once they have agreement to use the software. But anyone can apply to use the software as long as you meet the legal requirements for being able to have a copy.
Yeah, that's quite a little bit of a unique use case, maybe situation that other people maybe won't encounter so much, I guess, with more run-of-the-mill software.
Yeah, it's a difficulty. I prefer if everything was open source and people wouldn't use it. People would use it for good ethical reasons, but unfortunately we can't guarantee that in this world. So,
wow. Well, I think I've covered most of the major topics I really wanted to ask you about. Is there anything I should have asked that I didn't ask?
If people wanted to get involved in open source, how would they go about doing it? I think is a good question. So if you are a software developer and have never made an open source contribution before, basically the biggest platform in the world for open source software was called GitHub. This is a website that's owned by Microsoft now, where users can publish and distribute their open source software, and developers across the world can add changes to software and report issues. So the first thing you should do is get a GitHub account, and then working on open source is kind of difficult because there's so much you could do. There's so many projects you could get involved in.
Where do you start? Yeah.
So I just recommend picking one thing you're interested in. And if there's one piece of software which doesn't do what you need it to do, or it doesn't have a feature which you think that it should have, you can start speaking to the developers of that software and say, hey, what if I added this? Just start a conversation that way. And the most important thing is to try and finish something, because it's very easy in open source to start something and never finish it. But for it to have any impact, you need to finish it. So just concentrate on one thing and make that one thing really good is the advice I'd give.
Yeah, excellent advice. We've definitely had a lot of people coming to the Engineer Cafe, and we've been doing events on Git and GitHub, trying to get more people involved with this type of thing recently. Yeah, it's definitely a great place to start.
Yeah, and it would be wonderful if companies would give, maybe a few hours a week of staff time, allow staff to develop open source software on company time, because the benefit for upskilling the staff is incredibly useful, and through that your own company's software will improve because the developer skill level will improve. So I wish companies would be able to contribute some more staff time to support open source.
Right, and yeah, like you say, it's not just a cost. The skills gained and the actual software produced is often used at work anyway.
Yeah, that would help. I know open source has some major issues with diversity and representation. So most open source developers are white men. So if companies would actually allow people to work on open source just a little bit a week at work, then it means people who don't have, lots of free time, like, kind of white single men, women and people with families and babies, and they can get involved because there's this incredible talent pool of people who are not able to contribute to open source. So that's something I really wish the open source community will work on, is making it more open and inclusive. And then
I think fantastic. We can only gain from having more people and more diverse representation in software in general and in open source.
And especially I'm in the science field. The benefit of open source in science is incredible. So computer science, especially. So recently ML, machine learning and AI, everything they do is open source. All papers they publish, code on GitHub. And it massively accelerates the pace that research and development progresses. So instead of having to do something from scratch yourself, you have a solution there ready waiting for you, which you can then improve on yourself for your own problem you're working on. So the benefit for society and for development is massive.
Fantastic. Well, thanks for taking the time to tell us all about your work and about your experiences with open source. Thanks a lot.
Thank you.